Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Thank you for choosing IT Pro TV, helping you learn wherever you go. I'm Zach Memis, your host for this episode of Net Plus. And we're going to be looking at the TCP IP model with the one and only Wes Bryan. Wes, glad to have you here. Thanks.
Hey, Zach, thanks for having me here. That's right. You know, we were going through the objectives, and, you know, we like to be thorough. And I just happened to be looking through the objectives, and, well, we've seen the OSI model, right? And we've talked about in other episodes, we've talked about the open systems interconnection model that really goes back to, you know, they say the 80s is when they started standardizing this, but I believe the model actually goes back a little bit farther, like 1977 or so, right? So we've talked about that model, and we have mentioned, well, I should say I've mentioned in passing, I've mentioned TCP IP through the whole entire course.
Yep.
But we haven't really defined what TCP IP is, right? So even though it's not actually called out by the exam objectives, you better believe that you're going to see stuff about TCP IP on the exam, and it is one of those things that's kind of implied. So in this episode, what we'd like to do, since we've already recorded our OSI model, if you're not familiar with that, by all means, go back and check it out, right? Watch the OSI model there for more in-depth on the OSI itself. We're also going to, in this episode, we're going to talk about the Transmission Control Protocol Internet Protocol Suite, right? The protocol stack, or the abstract model that really is the most common model that is used today. And then at the end, what we'd like to do is come back and kind of, in this episode, we'd like to kind of come back and then tie it all together, right? Look at the OSI model and then look at TCP IP, kind of put them side by side, and, well, let's see what they're doing, right? Do they agree on certain things? Do they disagree on other things, so that you can have a little bit more thorough understanding of why do we say layer one, and that means the physical layer, and in other, you know, terminology, layer one actually defines the characteristics of, let's say, MAC addressing and the physical media. Well, wait a second, you know, what's going on here? So that's one of the things that we're going to do right here in this episode.
Let's do it.
All right, so let's go ahead, TCP IP basics, all right? Transmission Control Protocol, Internet Protocol Suite, even though they are two protocols in the name, all right, it's actually a family of technology, an entire suite of technologies here that also are formed kind of like OSI in an abstract layered model. All right, and in fact, let's go ahead and kind of look. I've got a little diagram here, and these are the layers within the TCP IP model. Now, this goes way back to the days, the 60s, when the United States Department of Defense, and more specifically DARPA, Defense Advanced Research Project Agency, was developing communication protocols for what was back then called ARPANET, right? We've kind of mentioned that. That was the predecessor to our internet, and then at a certain point, ARPANET kind of split, if you will. Well, the military went to MILNET, and that's their lockdown military network, and ARPANET was released over into the public domain, would later become the internet. Well, this protocol stack actually goes back to those very earliest days when they were trying to route traffic across the ARPANET. And what the one big thing that they wanted to do is they wanted to be able to route traffic across ARPANET, and the individual local area networks connection technologies. TCP would be independent. TCP IP would be independent of that, right? So it's been around for a very long time. It is the most common network communication implementation used by the internet today, right? When we say internet, right, I want you to think of IP, Internet Protocol. That's the most common addressing protocol out there today. Now, it's by all means, it's not the only one, right? We've had others as well. We've had things like Novell had the IPX, SPX, the Inter Packet Exchange, Sequence Packet Exchange, and it's not as common. It kind of went by the wayside, proprietary, and for whatever reason, never took off. Apple was another player, big, you know, competitor in technologies. They had Apple Talk, right? Apple Talk was another protocol out there, but again, ultimately, what it came down to is the most commonly vendor-distributed protocol suite would be TCP IP, and it would become later on what we use and what we use today for internet communications. Now, it has other names. You might hear it referred to, not as common as TCP IP. That is by far what everybody recognizes once in networking, right? But it has other names too. Like, for instance, it was called the DARPA model, hence because DARPA was the one that invented it, right? Imagine that. Or sometimes you might even hear it called the DoD model, right? the Department of Defense model too. All right, so we do have to be aware of transmission control protocol, internet protocol suite. Again, the two protocols that perform a lot of the major functions are TCP IP, hence why it's in the name, but it's not the only one. So let's go ahead and let's look at our slide here and let's talk about some of the services that we can see, and then what we'll also do is go a little bit into some of the protocols that you can see in each of these layers, all right? When we look at the application layer, all right, the application layer, it provides things like network resource access, right? If we've got an application that we need to exchange data, and there's some kind of application data exchange, well, guess what? The application layer is the one that gives network services to those applications, right? Provides those resources. Provides things like name resolution, right? When we need to take those names and resolve them to the lower level IP addresses, well, guess what? The application layer is the one that provides that functionality and that service for us. It also does things like data encoding, all right? You say encoding, decoding, right? Think of it as formatting or syntax. It also has the syntax functionality inside of the application layer as well. It provides things like, for instance, encryption and compression. Right, that all happens right here at the application layer too, as well as things like network management too. And we'll come back and we'll look at some of the protocols too. So this will make it hopefully a little bit more added sense to some of the services that it'll provide. And if those of you have already been studying OSI model, when I start saying, hey, it provides things like name resolution, you probably got in the back of your head maybe one of the protocols that I'm talking about, but I'll leave a cliffhanger here and we'll come back to that in a bit, right? It'll be a little test before the test, right? If we move down the layers, right? If you ever heard, just like we mentioned in the OSI model, we say, hey, moving down the protocol stack or moving up the stack, well, look at the 4 layers here. That's the stack, right? And if you're moving down the stack, now we're going from the application to the transport layer. Well, the transport layer, what does it do? It provides things like connection-oriented services, if you will, provides things like sequencing and segmentation, which I'm going to come back to because it's kind of specific here with TCP IP versus like the OSI model, because there are some differences, because we definitely want to look at that. One of the things to keep in mind is that TCP IP is optimized, highly optimized for network or internet communications, right? The OSI model is a little bit, it's rigid, right? Things aren't always as clearly defined. See, the OSI model has what I call gray protocols, right? And what do we mean by gray protocols? Well, you've heard it's either black and white, right? So you're either colored black or the color is white, and some people will say, but there's shades of gray. It didn't fall into this category, and well, it kind of fell into that category, right? Well, that's why I call them gray protocols. Like for instance, let's take a network interface, a network adapter, right? The network adapter, if you will, it's Ethernet, let's say an Ethernet adapter, right? Well, that defines things that sit at the data link layer, like the media access control layer, if you will, as well as the physical layer, right? The Ethernet twisted pair implementations, that's the physical layer, right? So that's like a OSI gray protocol, right? Kind of sitting in between. We don't have that problem with transmission control protocol. All of those functionalities sit at a well-defined single layer, right? So again, very, very specific, right? Not a lot of room for tolerance for these gray level protocols. Everything is clearly defined at the levels. All right, so with that being said, we move down to the transport layer. Continuing on, I want you to keep in mind we get connection-oriented services. Those of you that have already looked at the OSI model and maybe seen some of our other episodes in the Net Plus course should probably know one of those protocols that I'm talking about, as well as providing things like acknowledgement services, right? If a packet needs to be retransmitted, right, at that transport layer, it's going to call back across that wire and it's going to say, hey, I just lost sequence or packet or datagram, if you will, segment, more importantly. I just lost segment, whatever. I need you to send it so that I can reassemble that PDU so that we have the information, right? So acknowledgement services, as well as the part of that also being things like packet recovery, too. Now, when we look at the internet layer, right, the internet layer is important, and I want you to think about the name internet layer coming up again as we move through it, right? Internet layer provides things like our addressing, things like routing, packetization of our data, right? So packaging, if you will, turning it into a packet. Things like, for instance, the IP to the link layer, right? The link layer address resolution. And when I say link layer, we'll come back to what I mean by that, right? And it also provides things like multicast communications, right? When we need to route multicast communications to those specific few within that group, guess what? It's happening here at the internet layer too. But it also does things like, for instance, controlling congestion. We can do diagnostics, if you will, and flow control. For instance, that squelch message that says, hey, you're sending too much information into the network adapter. You need to slow down, back off a little bit, or I'm going to start dropping packets. Or you're talking too slow. Come on, speed it up, right? So it does things like flow control as well. That all happens there at the internet layer too. Now, the network interface layer is interesting, all right? Sometimes called a link layer too, but don't get it confused with the data link layer, the OSI model, right? They're not one and the same, right? But the network interface layer, right? What does it do? It provides access to your medium. All right, whether it be a wireless medium or unbounded radiated energy, or whether it be bounded media, there's some kind of fiber optic or wired copper communication, right? Receiving and placing that data, so receiving it off the medium, placing it on the medium, so not only giving you access, but actually performing the function of putting that information on the medium and taking it off of the medium. One of the great things about the network interface layer there, Zach, is the fact that it is frame format independent. It doesn't matter what the frame size is. It's a transmission control protocol says, I don't care about that. LAN communications, LAN technologies, you take care of that. I'm not going to worry about it. I'm out of here. No, not really. It doesn't matter. It's access method independent. It doesn't matter if it's using CSMA or CD or CMSA CA. Doesn't care. It's independent of that, right? And that's one of the great things. And it's why the Department of Defense wanted it so good, because they said, hey, we want to be able to route traffic across these different vendor networks, and we don't want to get vendor locked, right? Again, at the network interface layer, transmission control protocol turns a blind eye to whatever the media access method is, your frame format, and again, the medium itself it doesn't matter either.
Hey, Wes, now is the DoD exclusively using MILNET? Or do they also use regular internet?
There are some in the public domain, and that's one of the reasons we have one of the TODs, the top level domains, is actually MIL, and it is military. So they use public networks too, but anything that is, top more, secret. Yeah, well, not even, maybe top, well, definitely top secret, but they also have their isolated military network, and again, it's fairly air gapped as far as I know, but. Cool. Yeah. Let's see. The other thing, too, about the network interface layer here, the other thing that is great is the fact that it doesn't, it assumes an unreliable medium, an unreliable link. And that's one of the interesting things. When we come back to our comparison over TCP IP model, we'll see why that matters. What are the comparison? What's different here, right? Just remember that the network interface layer doesn't provide acknowledgments. It doesn't provide sequencing. If you need reliable delivery, it's going to have to be provided by the transport layer. And if you are using unreliable connection services at the transport layer, don't expect the network interface layer to do it. That's going to be required up there at the application layer. The upper layer protocols are going to have to support that. Makes sense. More specifically at the transport layer. All right, so that is a little bit about our TCP IP model. Mm-hmm. All right, let's talk about some of the other things that we can see here, right? So in our, got another little slide here. When we talk about the application, right, it provides application services and data exchange. Some of the protocols that we see here, you will see we have things like HTTP, or whether it's secure HTTPS, right? Because remember, encryption is also handled by this application layer. Things like data exchange, more specifically, things like your file transfer protocols, right? NFS, Network File System. What else? FTP, AFP, Apple Filing Protocol. All of these different file access and transfer programs are at the application layer. Your email protocols, right? SMTP, Simple Mail Transfer Protocol. POP3, Post Office Protocol version 3, IMAP, your Internet Message Access Protocol, right? DNS, Telnet, terminal emulation software. All of these are at the application layer. These are examples of application layer protocols. So some of you are probably saying, oh, is that why he said the application layer is providing name resolution services? Aha. That's right, exactly. That's where DNS sits there at the application layer, right? Mm-hmm. Now, the transport layer is also sometimes known as a host-to-host layer because it provides the host-to-host communications. And that's important to understand because guess what? Transmission Control Protocol sits here. And we know what TCP does, right? Transmission Control Protocol, remember I said earlier, that transport layer provides those connection-oriented services, sequence and segmentation, or sequencing and segmentation. It's all part of the Transmission Control Protocol functionality, which we've talked about already in other episodes, including the packet recovery. Now remember, if you have applications or upper layer protocols that provide some kind of checksum, and you don't need the overhead of transmission control protocol, but you need just sheer speed, that's where, well, you're going to get UDP, right? User Datagram Protocol. So the transport layer, again, the two major transport protocols, TCP and UDP. We get back down to the internet layer, kind of a recap. Remember we said addressing and routing? Well, guess what? IP, the Internet Protocol. That is the addressing part, right? Routing protocols that we also talk about as well, things like OSPF, right? ISIS, EIGRP. Things like IGMP, right? Internet Group Management Protocol. That is your multicast control protocol. Remember we said there at the internet layer that the multicast communications are controlled by this layer? Well, guess what? It's IGMP. ARP. Remember I said an IP to a link layer address resolution? The Address Resolution Protocol. We've already talked about that. Remember, receiving those communications from IP and say IP says, well, I don't know what the MAC address is. Oh, ARP, you're sitting here with me. Here, let me hand that over to you. You go take care of that and find out the MAC address, and when you've got that answer, just return it to me, right? So all of that is happening right there at the internet layer, likewise too. Now, the network interface layer, this is what actually places the data on the physical medium, right? Ethernet, token ring, fiber distributed data interface, or FDII, and again I always have to say FDII just because it's fun to say. SONET, right? Well, if you're here in the States, it's SONET, you know, part of the American National Standard Institute. That's the synchronous optical networking. If you're in the UK and you're following the International Telecommunications Unit, they're going to call it SDH, right? Synchronous Digital Hierarchy. So again, just a couple different terms for the same type of communications. So, you know, when we talk about this, you know, where do we see some of these technologies when it comes to the transmission control protocol? Well, we can actually see this, and, you know, if we kind of switch the order rather than going from application down the stack, hopefully that makes sense now, we're going to start at the bottom of the stack, the network interface layer, and we'll work our way back up the stack. In fact, you know, the network interface layer, right? What does it define? Well, let me show you what it defines here. We've actually got an example here, right? Am I using copper-based media? And in this case, would it be twisted pair media? Would it be coaxial media? Am I using fiber optics versus, you know, single mode fiber, you know, SMF or MMF, multi-mode fiber, right? Again, are you using a wired connection? If you're using Ethernet, the media access method is going to be the carrier sense multiple access collision detection. If you happen to be using a wireless access point, right? Well, wireless access points today, especially the home ones, they got a lot of functionality built into them, right? They're doing Ethernet, so they're doing wired, so they're doing a form of CMSA CD, as well as the wireless radiated energy is the CMSA-CA, right? The Carrier Sense Multiple Access Collision Avoidance. Are you using a CSU-DSU module, right, for you in your switches? Are you using a wireless adapter versus a wired adapter, right? Well, all of this information is going to be basically what's happening at the network interface layer. All of that is defined, right? Clearly defined. Then, you know, when we get up to things like, for instance, our also at the network interface layer too. Let me show you here. If I can get logged in on my Windows 10 machine, we'll just kind of drop down to PowerShell or a command prompt here. And we look at things like, for instance, doing ipconfig, right? And we do a /all. I can see things like, for instance, I can see the physical address, right? Right there. There's the MAC address. That's all defined there by that network interface card, you know, the network adapter, the network interface layer, I should say. If we look down into our adapter settings and we right-click and we choose the properties of the network adapter, well, I can hover right over the physical network adapter and see what that MAC address is, right? All of that's defined right there at the network interface layer. What medium you're talking about, what media access method, defining how we place the media or the data on the media, as well as some of those addressing protocols, if you will, like media access control address, a MAC address, right? Then if we move up to the internet layer, right? We'll go ahead and clear the screen. I can spell CLS, would be doing good. And I choose something like route, right? And I do a route print. Well, here now we're up to, you know, that second layer. And that's where it gets tricky, right? Because if we say layer 3, and it's talking about IP, you're talking about the layer 3 of the OSI model is the network layer. But if you're talking about TCP IP, it's layer 2. See the confusion here?
Right.
So what are you talking about, layer 3 or layer 2? Well, I don't know. In context, I got to figure out, are you talking about OSI? Because if you're talking about OSI and you're talking about IP, you're talking about layer 3. But if you're talking about transmission control protocol, that happens at the internet layer at layer 2. And that's why I want to kind of establish what is going on here, right? So we have our routing, right? Our routing tables, our IP addresses, where the routers operate, right? That is going to happen at the internet layer. And I want you to think about that. Internet layer. Why do they call it the internet layer? Because the network interface layer just defines more like the local area network communications. Even though it's vendor independent, it doesn't matter what the protocol is. That's really your LAN communications. Then once we want to hop out of our networks and go across networks, hence the internet with the internet protocol, keep saying internet so it'll sink in what that layer is, right? Just don't practice it till you get it right. Do like my favorite guitarist said, Buddy Guy, practice it till you can't get it wrong, and then you know it's going to be right. So just keep going over these things, right? So you have, for instance, here the internet layer. But then we can see other information too, right? We can see the information of the transport and that application layer, but what we're going to do here is we'll show you some of those protocols. I'm going to go ahead and let me fire up Wireshark here, and we'll do a packet capture, and we'll kind of look at some of this information here. And let me go ahead and put this filter in here real quick. And I'm going to connect over the network back to my server. I'm going to connect to its administrative share. Now, remember that I told you that at the application layer, we had, what did we have? We had file transfer protocols, right? File access protocols. File access at all, right? Well, SMB is server message block, right? That is also up there. Now, I didn't mention it, but SMB, Samba, this is all part of the application layer as well, right? Now that I've actually connected to a Windows shared resource across the network with this UNC path, I should see server message block has kicked in at the application layer and said, hey, let me negotiate the communications between File Explorer here and that server that you're connecting to viewing its files and folders over the network, right? So now that we've done that, we'll go ahead and we'll just kind of stop this, and I'll stop the packet capture right here, and I see things like DNS, right? And in Wireshark, I definitely recommend getting Wireshark so you can kind of see what's going on here, but notice that we have, we've got domain name system, right? That's your application layer. We have right here, we have the transport layer, right? Now we're moving down that protocol stack, right? So application is DNS, right? The transport layer, we're using connectionless, right? This was a connectionless, is a UDP DNS query, right? So it's connectionless. We can see the destination port, right? So we can see the port information there, port 53, right? Which, and that's another thing to keep in mind that's kind of interesting. Inside of the application layer in TCP IP, it performs some of the same functions that the session layer does over there at the OSI model, right? And that's why we can see things like here in the transport layer, right? We can see things like, for instance, the ports here. I can see DNS, and we'll see a little bit more of this coming up where you can actually see some of the session layer information that's kind of built right into the application layer of the TCP IP model. Let me kind of scroll down here. Oh, here's one, right? So what do I have right here? Remember we said transmission control protocol. TCP is a connection-oriented service. Well, how does it happen? Right? Well, it happens through what's known as a TCP three-way handshake. All right? Hey, I need something. Okay, I acknowledge the other side. I acknowledge that you need something. Hey, now we're connected and we can set up a communication. So three-way handshake, what we have is a synchronization request packet. Yeah, this is kind of cool when you get down into the protocol analyzer. You're like, wow, that's the protocol doing what it's supposed to be doing. It's setting up that connection-oriented session. It's saying, hey, I need to synchronize with you. And then the end party, the other system, calls back and says, okay, I acknowledge. It's called a SYNAC, synchronization acknowledgement packet. I acknowledge that you want to synchronize. And then finally, to set up that connection, it sends back the acknowledgement, right? So that's the last one. So you have the TCP three-way handshake going on here, and we can see that information right here in the protocol stack, right? And let me go ahead and select this one. Now, here's another thing to keep in mind. Some people believe that in every single communication you do, You're going to work down the application to the network interface, back up the network interface, all the way to the application. That isn't necessarily true, all right? Because sometimes transmission control protocol is just communicating, right? Hey, hold on, application. You need to stop. Don't send me your information yet. You need a connection-oriented service, right? That's what you're telling me? Hold the horses. Let me go ahead and set that up with a TCP three-way handshake, right? That's why we don't see any application layer data, right? This is the very first acknowledgement going out. So transmission control protocol says, wait a second, I see you're trying to give me this, this SDU, this service data unit. Hold on, just hold on to it. Let me go ahead and pick up the phone call, and I'll get that phone call started for you and everything, and then you can pull your information down. And what we see after that, right? Notice that we don't have any application layer data coming out here, right? These 3 packets that I've captured are all transmission control protocol. But then notice what happens when we hit the first, remember I said SMB? Mm-hmm. We hit the first SMB, and now I have application layer. And in between the application layer, we have some kind of session layer, like I said, kind of related to the OSI model. But at the application layer, it bundles in those functionalities. And we're going to see that coming up, probably in a part 2 here coming up. But you can see that there it is. There is SMB sitting right on that transport protocol, which is sitting right on top of IP, which is then finally encapsulated in an Ethernet frame. And then it's turned into an electrical current, and it's sent across the wire between your endpoints. So those are some of the things that you can see in transmission control protocol, internet protocol, or the TCP IP model. However, we've got a couple more things that we need to round off because I want to jump back and kind of talk a little bit more about the protocols, some of the things that you can also see in here, and then round it up with a comparison of the OSI and transmission control protocol, internet protocol model, or TCP IP model, so that if they ask you questions on the exam, you'll be able to get them right.
Fantastic job, Wes. Thanks very much. TCP IP model, part 1, there will be a part 2. So make sure you see both parts. Very important stuff. And make sure you watch everything in the Net Plus series that Wes has put together for you, because he's done a great job. And you can use this information now and in the future. And while you're in the course library, there's thousands of other videos, and they're there to help you go further. So check them out, too. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Wes Bryan.
And we will see you soon.
Thank you for watching IT Pro TV.